So this is our cone. It's 15 meters high. We have 12 meters of water inside of it, and we want to raise the water up to the top of the cone, which is 15 meters. The radius is 4 meters, and our change in x is x sub k, and our change in radius is r sub k. Here's our general equation. Work equals the integral from a to b, density times gravity times area function times height function, and in terms of x. So our unknowns are obviously work. Our knowns are density, which is 1,000 kilograms per meters cubed. Gravity equals 9.8 meters per second squared. And we're also trying to find our area function and our height function. So we know our radius is 4 and our height is 15 for the cone. And we also know that our change in radius is r sub k and our change in height is x sub k. Thus, through similar triangles, we can say that r sub k over x sub k equals 4 over 15. Then, if we're trying to solve for r sub k, which we need to because we're trying to find our radius, we get r sub k equals 4 over 15 x sub k. Now we're solving for our area function, and we have pi r sub k squared. Pi comes out here. We have 4 over 15 x sub k squared. This is from our previous calculations. Once we calculate this, we get pi out in front, 16 over 225, x sub k squared.
So now we're going to solve for our height function, which is d of x, and it's going to be 15 minus x sub k. X sub k being the level of water inside of the cone. And we have the height of the cone minus x sub k.
Alright, so now that we have all of our things that we need to plug in, I'm going to calculate our work. So we have work equals the integral from a to b. A is going to be 0, b is going to be 12. Our density is 1,000. I'm going to save units for later just to avoid clutter. Our gravity is 9.8. Our area function, is pi times 16 over 225 x sub k squared. And our height function, the d of x, is 15 minus x sub k. And that's all in terms of x. Alright, so now we took out all of our constants to make it more convenient and easier to solve our integral, which is now here.
Now we've simplified our constant, and we've distributed, and now we just have to find the integral from 0 to 12 on this.
So now we have solved our integral, and we are going to plug in our numbers of integration to get our work done. So we have our constants, and we plugged in our numbers of integration. As you can see, our next step will be to solve all of this and have our final answer. Now we have our final answer. The work it took to push the water from 12 feet high, or 12 meters high to 15 meters high in the cone was 7.6 times 10 to the 6 joules. We use joules because we're using the metric system, SI units,